Hello everybody and welcome. In our video today we'll be looking at binary search. Now I will be making use of these lovely cards from Digital Schoolhouse to show you how binary search works. Now in binary search, unlike linear, the data set, so the values in the list must be ordered. So you can see here I'm using A as 1. So you can see all of them are ordered 1, 2, 3, 4, 5, 6, 7, all ordered. And those small tiny squares you see there represents the index position of each value in the list. Okay. Now there are 3 key pointers that we need when working with a binary search. One of them is our lower bound. Now the lower bound pointer always in a first instance points to the first item in the list. Okay, so the value of the lower bound is always 0 in the first instance. So you can see there, straightforward. Now the upper bound pointer is the length of the list minus 1. Now you might be wondering, why subtract 1 from the length of the list? If you look at the example we have here, the length of the list is 7. However, the maximum index position we have is 6. So if you work with 7, you would go out of range and then you would have an error in your code. So to fix that problem, you look for the length of the list, currently 7, take away 1, and that will give us 6. So you can see our upper bound there is 6. Now the key bit here is to then find our midpoint. Now this is a very good point for me to add that the binary search, a common term used in binary search is to divide and conquer. We're always looking for a midpoint and when conquering half of the list at every given point in time. To get the midpoint, we will add the index position of the lower bound to the index position of the upper bound and div by 2, not divide. Now I'm saying div by 2 because when we use div, we know we don't have a remainder. But if we do use divide, we would have a remainder, and that's not good for index positions. So in this case, you then have 6 there plus 0 there, which is 6, of course. And then if you div that by 2, that will give you 3. So our midpoint becomes 3. So the next thing we do, I should add also that let's say, for example, we've been asked to look for 5 of diamonds. Okay, let's say we've been asked to look for 5 of diamonds. So at this point, we will check the value in the midpoint. So the value currently held in our midpoint is 4. We will then check, is 4 equal to the value we're looking for, which is 5 of diamonds? No, it's not. Now because it's not, we then move on to the next bit, and the next bit we'll see is to check if it's greater. Now if 4, for example, is greater than 5, then we would have to move our upper bound to midpoint minus 1. So our upper bound will come down to 2 that way. Okay, and then we'd have to find our next midpoint, which will be 2 plus 0 div 2, and that gives us 1. But that's not the case here. So in this example here, our midpoint is smaller than our value, than the value we're looking for. So because the midpoint is smaller than the value we're looking for, our lower bound will then be the midpoint plus 1. So our lower bound will be 3 plus 1, which is 4. It therefore means that we need a new midpoint. Our new midpoint will then be the index position of our upper bound, so our upper bound, which is 6, and then our lower bound, which is 4. So 6 plus 4 gives us 10. 10 div 2. Again, we're not dividing. 10 div 2 gives us 5, which means our midpoint will then be 5. All right. And then we check again, is this 6, this value in our midpoint, which is currently 6, is it the value we're looking for, which is 5 of diamonds? Of course it's not. We then check, is it greater than the value we're looking for? Because it's greater than the value we're looking for, our upper bound will then be the midpoint minus 1. So upper bound will be midpoint minus 1. So our upper bound at this point is pointing there. Okay. And our midpoint, of course, will be our lower bound, which is 4. And the upper bound, which is 4. So 4 plus 4 is 8. Div 2. Now 8 div 2 gives us 4. So our midpoint will be 4. And then we check, is 4, which is the value of our midpoint, equal to the value we're looking for? And yes, it is the value we're looking for. And because it's the value we're looking for, we will stop, because found is now true. Okay. Now, you might wonder, at what point will they stop? This search would stop where found is true, so our midpoint is the value we're looking for, or where our upper bound is greater than our lower bound. I hope this was clear. Thank you. Bye-bye.